Hey folks, how's it going? It's Mr. Murray coming to you with a video on adding and subtracting rational expressions. So this is a follow-up in a series of videos that I've made, right, in which first we talked about graphing rational functions, then we talked about multiplying and dividing rational expressions. Now we're going to talk about how do we add and subtract them. And as with multiplying and dividing, what we're going to see is that there's a strong overlap between when we worked with fractions in elementary school and when we're working with rational expressions now. Okay, so my goal in this video is to, again, take you through the basics of how do we get these figured out, and then provide you with an opportunity to see me work through some problems, and then to give you an opportunity to go through some problems yourself. Okay, so to start, I thought I'd start by thinking about how would we add or subtract fractions ordinarily. So what we learned when you first started working with fractions is we probably learned the first thing you want to do is you want to get the denominators to be equal. So essentially, either the denominators are already equal and this is done, or the denominators are not equal and you have to make them equal. Okay? And then once they're equal, all we do is we add or subtract, depending on the operation, across the numerator, right? Some people say like the top. All right, and then you keep the denominator the same. Okay, so basically what I'm going to do is first let's try to apply to these problems right here. So I've got 2/5 plus 1/5. So my first thing I want to do is get the denominators to be equal, and in this case they already are. So what I'm going to do is I would then add across the top. 2 plus 1 gives me 3, keeping the denominator the same, 3/5. And think about it, if you have 2 of something and then you add 1 of something, you have 3 of those things, right? If I have 2/5 and I add in another 5th, I will have 3/5. Now, the trick is when the denominators are not equal to each other. Well, that's going to be a little bit more challenging, and so that's a scenario where we're going to have to figure out how to make them equal to each other. And in doing so, we're going to think about how that works when we have rational expressions as well. Okay, so the first piece is we need to be able to find the least common denominator. Okay, so basically when the denominators weren't the same, what you did was you found the least common denominator. And the least common denominator, or LCD, of two fractions is the smallest possible denominator, hence the word least, that is a multiple of both of those fractions denominators. Okay, so I'll give you some examples just so you can see what I mean. So let's say we have 8 and 5. I'm going to ask myself, what's the smallest possible number that's a multiple of both 8 and 5? And that number is 40. If you do the multiples of 8, you get 8, 16, 24, 32, 40. See, 40 is the smallest number that's a multiple of 8, and because it ends in a 0 or a 5, it's divisible by 5. So this would be the LCD, the least common denominator. Okay, so sometimes, as you can see though, what we did here is we literally it's just the product of those two numbers, right? 5 times 8 is 40. And that's sometimes what the least common denominator is. And the reason that is because 8 and 5 don't have any common factors. Sometimes when there's common factors, you will get an LCD that's not just simply the product of those two numbers, right? Okay, though that is always an option, and that's something we can talk about when we do the adding and subtracting of rationals, where it's a little bit less obvious how we would do this. Okay, here, this is a little bit different of a case because the least common denominator here is actually 9. Okay, so there's also the case where one denominator is a multiple of the other denominator. So one stays the same, and then you just do something to turn the other one into that denominator. So, for example, we could multiply by 3 to turn the 3 into a 9. Finally, this is an example of one in which, so we've got 3/8 and 5/6. This is an example of one in which we have some fractions and their denominators have common factors, but the least common denominator isn't one or the other, okay? So if you look at 8 and 6, right? Well, actually what you'll find is the least common denominator is 24. Okay, so it's not just 8 times 6, right? Because 8 times 6 is actually 48. So it's a number that is not just the product, okay, but is again, it's a common multiple of both 8 and 6, and it's the least common one. So sometimes people also call this the least, sometimes people say the word least common multiple. They're related ideas. So the least common denominator is the least common multiple of the two denominators. That's another way to look at it. So this is with numbers, but what about when we have fractions? So what I'm going to assert is that the cases that you see here are similar here. So the first case we had, now the colors don't perfectly line up, but the first case we had was one in which there were no factors shared among the denominators. See here, we have x plus 4 and x minus 2. These expressions are completely broken down and they don't have anything in common. So this would be a time where you just simply multiply, as you saw there, you simply just take the two factors, or the two denominators rather, and you multiply them together. The second case is a little bit different because if you look at the bottom, and you should essentially, we need to get in the habit of always looking for an opportunity to factor. Always look out for that. So here's the example of the second case in which one is a multiple of the other. So the least common denominator here is 3 times x minus 2. All right, in other words, 3x minus 6. Okay, and then finally, you're going to see sometimes situations where you might need to factor a couple of things. So this is x minus 3, x plus 5, and this is x minus 3, x plus 3. So you can see they share this x minus 3. And so the greatest common factor here is we need to combine. So we need an x minus 3 and an x plus 3. So then it will be a multiple of x squared minus 9. And then I've already got the x minus 3, so I'm good here. So I add in an x minus 5. So just like the third case that you see up here, it's not just simply we take both of them and stick them together. It's something in between. So sometimes when you're simplifying these, you need to take the denominators when you find the least common one and just multiply them. Sometimes one is going to be a multiple of the other. And sometimes you're going to need to find a combination of the factors. But the key thing you need to know here is factoring is extremely important in this process, just as it was with multiplication and division. Okay, so now that we have the least common denominator, what we need to do is we need to set the denominators the same, because you cannot add or subtract fractions unless their denominators are the same. So what we need to do is, remember when we worked with regular fractions, when they had only numbers? Well, what we did was we multiplied the top and the bottom by the same number so that the denominator will be equal to the least common denominator. So in other words, here, I would multiply by 8 and by 8, because 8 over 8 is equal to 1. So the value doesn't change because multiplying by 1 keeps something the same, but the expression itself looks different. Here, so you can see here, you can actually see the fact that each one was multiplied by the other one's denominator. Okay, and so now you can see how if I asked you to add or subtract, you would now be able to do that because the denominators are equal. Now, 2/3 and 4/9, well, how do we do that? Well, 2/3 and 4/9, if I needed to do that, what I would do is I would say, well, look, the 9, I can leave that alone, so I'll work with the 2/3. So that would give me 6 over 9 and 4 over 9. And now I can add or subtract them. Finally, sometimes you need to get creative. So I know I need to make them 24. So this one I'll multiply by 3 and this by 4. Okay? So again, with fractions, there's different possible scenarios. One in which there are no kind of common factors among the denominators, so you just need to multiply the denominators by each other. Okay? You have scenarios in which one denominator is already a multiple of the other, so you just need to kind of fix up one. And then you have another case where the denominators have some kind of common factor, so you have to be careful and you have to kind of think about what you need to multiply to get the denominator to be equal to that LCD. And so my argument is with rational functions, it's not really very different. Okay, so let's take a look. So here, remember what I said. This is the scenario where you just take them and you kind of meld them together. Right? So that, remember, we said that the LCD was x plus 4, x minus 2. So to get that, what I'm going to do is I'm going to multiply by x minus 2 on the bottom, right? Because that's what I need to multiply by so that I get x plus 4 and x minus 2. And then because I multiplied the bottom by x minus 2, I have to do the same thing to the top. So now you can see that this is essentially equal to 1, right? Because it's something divided by itself. So the expression doesn't change, but now we achieve that greatest common, or I guess least common denominator. Okay, here we're going to do a similar thing, but now we're going to do the x plus 4 as well on the top. And now you can see both of these have an x plus 4 and an x minus 2. The fact that they're in a different order doesn't matter, right? Because the order that you multiply two things doesn't make a difference. You'll always get the same answer. So now all I have to do is just multiply across the top. And I'm not even going to bother to expand out the bottom because it doesn't matter. I know the bottoms are going to be the same because they're the same two things being multiplied. Maybe we just heard that little interlude from my cat. He's also excited to share a couple things. All right. So that's one scenario. All I'm doing is I'm multiplying by the other one's denominator. So the x plus 4, I use the other denominator of x minus 2. X minus 2, I use the other one's denominator of x plus 4. I can be assured that the denominators are equal, and then I just multiply across the top and I simplify. Okay, and then all I would do if I'm adding or subtracting is I'm just going to add across the top keep the denominators the same. Okay, the order again of the factors down there doesn't matter. Okay, scenario 2 is I've got this right here. So one is a factor of the other, and so essentially you need to always be looking for opportunities to factor. So something I can see here is I need to be ready to look for a greatest common factor, right? The fact that this is 3 times x minus 2. So we're actually going to leave this one exactly the same. But what I'm going to do is I'm going to multiply this, right, by 3 over 3. Because, right, this is 3 times x minus 2. So now this will be 3 times x minus 2. And up top, I've got 33. Okay, and now that I've got them having the exact same denominators, I can just simply add or subtract across the top and do any kind of addition or subtraction problem that I want. Okay. Lastly, I've got a situation where I'm going to have to get a little bit more creative. So on the previous page, you saw me factor this when I was setting the GCF, or I keep saying that, the LCM, least common multiple, or least common denominator. All right, so this is x plus 5, x minus 3. Okay, we always need to be looking, and I hope you guys can see the common pattern. It's not like you're going to have to factor anything more than a quadratic. Maybe at worst like a cubic, but it's all really straightforward stuff. Okay, there haven't been really any tricks. Then remember, what we do is we pull together. So basically, the least common denominator is I need the x. It has to have an x plus 5 and an x minus 3 in it. So it'll work with this one. And then I also need to have an x plus 3 in it, so that I get the x minus 3, x plus 3. Right? And you can also see it's got an x plus 5, x minus 3. So how am I going to get this? So what is this missing? It's missing an x plus 3. So what I'm going to do is I'm going to multiply by x plus 3. What's this one missing? This one's missing an x plus 5. So this one I'm going to multiply by x plus 5. And again, because you multiply by the same thing on the top and the bottom, the expression itself maintains the exact same value, right? Because you're multiplying by 1. So I've got 3 times x plus 3 over, right? So it's x plus 5, x minus 3. That was the denominator. And then I add in the x plus 3. And over here, I've got 7. And then I bring in my x plus 5. And then I have my original x minus 3, x plus 3. And then I have x plus 5. Now, notice they are not in the same order, but the 3 factors are exactly the same. Each one has exactly 1x plus 5, 1x minus 3, and 1x plus 3. So, therefore, I can freely add across the top or the bottom. Here again, I would distribute 3x plus 9, and this one would be 7x plus 35. So just please make sure you distribute. The other thing we probably want to talk about here are excluded values. So in this case, just don't forget x cannot be equal to 3, -3, or -5. Because if it's equal to -5 or 3, the first one will be undefined. And if it's equal to -3, you'd also have the second one undefined, okay? And so remember, if one of the things has a denominator of 0, it's undefined, it doesn't have a value, so you can't multiply by it. All right, so now let's bring it all together. So essentially, this is the process. 1, you factor everything you can. 2, you find the LCD and you get all the denominators equal to the LCD. So that way you can add and subtract across the top keep the denominator the same, just like with a fraction, and you have your final answer. Let's take a look at what this looks like for some examples, and then I'll have some for you to try. So here we can see that there's nothing to factor. Okay, these are all linear, so I can't break them down. So I'm in a little bit of a pickle. So what I'm going to do is I'm going to multiply this one by 1 plus x over 1 plus x. And this one I'm going to multiply by x over x. Because that way I can be assured, well, I know that x times 1 plus x is equal to x times 1 plus x. So I know that both denominators will be the same. So now on the top, I've got x over x times 1 plus x plus, okay, this is going to be a difference of squares. 1 minus x squared, right? 1 plus x, 1 minus x over x times 1 plus x. Okay, so I add across the top, and I get negative x squared plus x plus 1 over x times 1 plus x. Keep in mind our excluded values here. X is not able to be equal to 0 or negative 1. All right, on the second one, you can see this is a case where the denominators are already the same. So I simply just subtract across the top. So I have 4x to the fourth, and then that won't combine with anything, but the 4 minus 8 gives me a negative 4. All right, and now I do need to take a look and see if I can clean up more. I see a GCF here, so I've got 4, and then I've got x to the fourth minus 1. And I can actually clean that up even more. So that's x squared minus 1 times x squared plus 1. And then the x squared plus 1's cancel out. So I get 4 times x squared minus 1, which is equal to 4 times x minus 1, x plus 1. Here there's no excluded values because there are no numbers such that x squared plus 1 equals 0. So that's an interesting one here. All right. Here, again, anytime we have an opportunity to factor, we do need to investigate that. So this is x plus 4, x minus 1, and this is x plus 2, no, x minus 2, x minus 1. Okay, so you can see the x minus 1's in common. The GCF that we need, or I keep saying that, darn, the LCM that we need to shoot for is x plus 4, x minus 1, x minus 2. Then we get the x minus 1, x minus 2, and we get the x plus 4, x minus 1. So we get everything. Okay, so what that means is this one is going to need to get multiplied by x minus 2. That's what's missing there. And this one's going to need to get multiplied by x plus 4 because that's what's missing there. So I get x minus 2 over x plus 4, x minus 1, x minus 2, minus, right, x plus 4 over x plus 4, x minus 1, x minus 2, and then I simply going to add a subtract across the top. So the x's cancel, negative 2 minus 4 becomes negative 6 over x plus 4, x minus 1, x minus 2. Okay, excluded values here. X is not allowed to be equal to negative 4, 1, or 2 because any of those numbers would make one or both denominators undefined. Or rather 0, rather, so it would make the expression undefined. All right, Now here's an interesting one. So x squared minus 4, I need to immediately factor that. That's x plus 2, x minus 2. That is a difference of squares. So it looks like I just need to multiply this one by x minus 2 on top and bottom, and I'll get that. So that means this one stays the same, and this one becomes x plus 5, x minus 2 over x squared minus 4. So what I have is this, when we do need to expand that out, I get x squared plus 3x minus 10. And then I would do 3 minus that. So I'd get negative x squared minus 3x plus 13 over x squared minus 4. All right, last one is going to involve when we work with three things. So it's the exact same idea, except I now need to make all three denominators equal. So I have to consider the least common denominator of all three things. So I'm going to again factor every denominator. So this is x plus 2, x minus 2, and I don't much like the x down there. So I'm going to factor out a negative 1. This becomes a negative x minus 2. Okay? So you can see here that essentially I need x plus 2 and x minus 2. So this one I'm going to need to multiply by x minus 2. The middle one will stay the same. That one's good. And this top one I'm going to multiply by x plus 2. Okay, so this one x plus 2, x plus 2. This one x minus 2, x minus 2. The negative sign, I'll pull that out and turn this into a plus sign, because the fact that that's negative makes the whole fraction negative because the top is positive, and so we're essentially minusing a negative or adding a positive. So the top is x minus 2 squared, or x squared minus 4x plus 4. Then I add my 1. Then I add x squared plus 4x plus 4 all over x squared minus 4. So let's see what we can do here. So I've got some terms that are going to cancel out. Okay. And so what I've got is x squared plus 9 over x squared minus 4. So that's the idea here. Now, excluded values are going to be 2 and negative 2, because that would make one or more of the denominators equal to 0. All right, so if there's any questions you have at this point, please go back and rewind and take a look at everything I've done, because I'm about to move on to some problems for you to try on your own. Okay, folks. So here's kind of a smorgasbord of problems for you to try. And so this is kind of spanning all different levels of difficulty and kind of thinking about what we just did. So feel free to try as many of these as you need. I will do a video review of all of them. Keep in mind, I am trying to be respectful of your time here and the work that you have for other teachers. So, I don't want you to be spending hours on hours on hours on the math, though I do want you to understand it. But in any case, please pause the video. Try these addition and subtraction problems, and then when you're ready, unpause, and I'll show you what I got. Okay, so let's begin with the first one, folks. And in the first one, the denominators are already equal. So I'm going to keep the denominators equal. Just bring them over, and I'll add across the top. So x plus negative 2x is negative 1x. 4 plus negative 2 is positive 2. Okay, so it's negative x plus 2 over x squared minus 4. Or, in other words, negative x minus 2 over x minus 2 x plus 2 or in other words, negative 1 over x plus 2. So you do need to really be that granular. And so one way you might be able to see it is by factoring somewhere else in there, but it is something that you need to be aware of doing. You have to really be able to simplify completely, just as with any fraction. It's a little bit more difficult when you're adding because it's not just as simple as multiply across the top and multiply across the bottom like we did before, unfortunately. All right, the second one's kind of like one we've seen before. So here, we just need to multiply this one by 2 plus x, and this by 2 plus x, and this one we need to multiply by x and x. Okay, no addition, no subtraction. The only thing that really works like this is multiplication, okay? So don't fall into that trap. Okay, and this is 2 minus x times 2 plus x is 4 minus x squared, only because it's a difference of squares. Okay, folks, so now we have this, and we're good to start adding across the top, or rather, I guess in this case, subtracting. So we have x squared, because we have 0x squared minus negative 1x squared, plus x minus 4 over x times 2 plus x. Moving on down to the third, I immediately see that I'm going to need to factor here. Okay, so this is actually a difference of squares. This is 3x minus 2, 3x plus 2. And this is a GCF. This is x times 3x plus 2. Okay, because you take out the x. So what I need is this needs to get multiplied by 3x minus 2, because essentially the GCF is x times 3x plus 2 times 3x minus 2. This one needs to get multiplied by an x. So I've got an x, a 3x minus 2, and a 3x plus 2. Okay, we make sure you do the same thing to the top and the bottom. Okay, so I've got minus 3x over x times 3x minus 2 times 3x plus 2 plus 3x minus 2, because you're just multiplying by 1, times x, 3x plus 2, 3x minus 2. So now the denominators are exactly the same, so we add across the top. Negative 3x plus 3x is 0, so all I'm left with is negative 2 over x times 3x plus 2 times 3x minus 2. All right, moving on down. This time I see a negative in front of the x squared. That's going to be interesting. So here, negative, I'll pull out the negative. So negative x squared minus 2. And you can immediately see that when I take out that negative, oh, okay. So look, it's the exact same. So what I'm going to do is, this is the same as this. Negative 2 over x squared minus 2, right? I can take that negative and move it out. So what I'm going to do is I'm going to turn this into a subtraction problem. X to the fourth minus 2, okay, minus 2 over x squared minus 2. And then it's just a matter of just multiplying across. So x to the fourth minus 4 over x squared minus 2. And now I am going to have to clean this up. So this is x squared minus 2, x squared plus 2 over x squared minus 2. So my final answer when I simplify is going to be x squared plus 2. So you do need to simplify your final answer. And again, those kinds of things don't necessarily show up in the process of doing these out until the very, very end. So you've got to always be looking for opportunities to factor. Look for those perfect squares and quadratics in particular, and the GCFs. Those are good to look for. Okay. This one's tricky, but what it might help you to notice is that this one is actually over 1. So this one needs to get multiplied by x plus 5 over x plus 5, because then they'll both be the same. So when I multiply this and I expand that out, I get x squared plus 7x plus 10 over x plus 5 plus x squared over x plus 5. So I get 2x squared plus 7x plus 10 over x plus 5. Let's see if I can't clean this up at all. So 2x, let's see if I can factor this. This is not going to be easy. I need to get to 10, essentially. And then adding to 7, that's going to be a particular challenge. Because the other issue is one number is going to get multiplied by 2. Let's see. I don't think I can get to 7. Let's see. Because I can think of... No, right? Because that won't work. You'll get 4. Nope. Oh, no, you won't. Let me see. No, I don't think you can get it to work. So I'm just going to leave it as this. If you could factor it, then that's something that you could investigate. Okay, last one. Just factor, factor, factor. So x squared plus 9x plus 14. That's x plus 7, x plus 2. This one here, this is x plus 7, x plus 3. So basically that means my least common denominator is I need an x plus 7. I need an x plus 2 to work with this. And I need an x plus 3 so it will work with that. So this one's going to need an x plus 2. And this one's going to need an x plus 3. So not the whole denominator because there's an overlap, but some of it. So I've got x squared plus 3x over x plus 7, x plus 2, x plus 3 minus x plus 2 over x plus 7, x plus 2, x plus 3. And now the denominators are the same, so we add across the top, and I get x squared plus 2x minus 2 over x over x plus 7 times x plus 2 times x minus 2. Okay, excluded values. We can talk about those as well. So excluded values here would be 2 or negative 2, because those would make these denominators 0. Excluded values here, negative 2 or 0. Excluded values here, 0, 1/2, or negative 1/2. Here it would be the square root of 2, because that square root of 2 squared is 2. Here it would be negative 5. And here it would be negative 7, negative 2, or negative 3. Okay, folks, last one. I have x plus 3 and x minus 3, and I'm going to rewrite this one as negative x minus 3. I'm going to take out that negative to put the x first. So we can see that what we'll just do is we'll just convert this to a subtraction. And so therefore what I need to do is my common denominator is x plus 3 times x minus 3, or in other words, x squared minus 9. So I'm going to multiply this one by x minus 3. This one times x plus 3. And this one times x plus 3. So here I get x squared minus 6x plus 9 over x squared minus 9. I'll leave it as x plus 3, x minus 3. Okay, here I've got x plus 3. And here I've got x squared plus 5x plus 6 over x minus 3, x plus 3. Okay. So it's going to be tricky. I've got x squared minus no x squared minus x squared. So the x squareds will cancel. I have negative 6x minus x, that's negative 7x, minus another x, so that's 5x's, that's negative 12x. Then I have 9 minus 3, that would be 6, minus 6, that would be 0. Okay, and my excluded values here would be 3 or negative 3. So hopefully, folks, you were able to find this video to be helpful. I know it was on the longer one, but please make sure you only prioritize the problems that you feel you need to work on most. And once you are really comfortable with the concept, hopefully you're skipping on with that and moving to the next one. Please make sure you do take a look at the problems for today so we can be ready to go and really kill adding, subtracting, multiplying, and dividing, and move on to our final little piece about solving rational equations. So best of luck. Don't forget to love math. And remember, you can do it. Thanks for watching, everyone, and have a wonderful day.